Hello student, today I will show how to do practicals based on logic gates. First I will take OR gate, and for OR gate IC number is 7432. An OR gate has generally it consists of two or more inputs and only one output. It is also called logical addition. And if output is denoted by y, therefore we can, and if a and b are two inputs, therefore we can say that y is equal to a or b, or y equal to a plus b. And in this case, output is high, that is output is equal to 1 when either input a or input b or both are at logic high. That is means if a equal to 0 and b equal to 0, you will get output equal to 0. If a equal to 1 and b equal to 0, you will get output equal to 1. If a equal to 0 and b equal to 1, you will get again 1. And if both inputs are equal to 1, you will get again your output will be at logic high. And therefore, see, first I will take one breadboard. First I will type here breadboard. Breadboard. See, then select here and click this breadboard and drag here. Okay. Now, my aim is to draw or verify truth table for OR gate, and for this, I will take IC number 7432, and therefore here I will write logic gate or gate gate. Here there are different gates. I will take first core or means here student core means which consists of 4 logic gates. Here I will take, if this dot indicates pin number 1, 2, 3, 4, 5, 6, 7, and here 7 is ground. Again 8, 9, 10, 11, 12, 13, and 14. 14 is for power supply. Okay. Now here I will take again, suppose here this is input A and input B. Here I will take one switch. Therefore here I will type switch. There are, I will take first slide switch. Here I will select. I take one more slide. I will here write. Okay. This is input A. See, input A. Similarly, I will take one more switch. Just copy and paste. And here I will write here. For this is equal to input B. Okay. Then I will reverse this position using this button. Same for here. Okay. I will align. Okay. Now I will take one battery of say 6 volt. Then type here battery. There are different types of battery. Here I'll take 1.5 volt. Okay. I want 6 volt. Therefore, the each of 1.5. Therefore, I will take 4 batteries. Okay. Therefore, total voltage is about 6 volt. 1.5 plus 1.5 plus 1.5 plus 1.5. So, total is equal to 6 volt, and I will make arrangement like this. Okay. Arrangement. These are the switch. Okay, see. First, then these are the, suppose this is A and B. Now I will take for output I will use LED. LED. will use LED. I will take a red color LED. Okay, and that is light emitting diode. Okay, and I will use one more resistor of 470 ohm. Here, therefore, type 470 and change unit. Okay, therefore, this is a 470 ohm. Now, I will first connect negative to the negative of this breadboard, then positive to lower one. Again, I will take one more wire from here, and this is your this is whole this horizontal line is positive. Therefore, I'll take one wire from this, and I will connect to the. Therefore, all these here you will get 6 volt. Again, upper line is negative. Therefore, I will take one wire from this, and I will connect to this. Therefore, this is the real one. This is plus, means for positive voltage, and this is your ground. Okay, and in this case, in 7432, pin number 7 is ground. Therefore, I will take one wire and I will connect to this line. Therefore, this is your ground. Therefore, I will take one more wire from pin number 8 and pin number 14, and I will connect to this line, that is the power supply. Okay, therefore this is the basic circuit, and therefore see A, this is your, these are the two inputs, 1 and 2, and 3 is your output. At output I will connect LED. Okay, and here student, this is your long, this is see, anode means positive and short length is cathode. Therefore I will connect one current limiting resistor to the cathode. I will connect here, and one terminal to the cathode of LED, and uh, another terminal of resistor is to the ground. Okay, because this is a ground line. This is connected to the see. Okay. Now, therefore, this C, pin number 3, see, 1, 2, 3, pin number 3 is output. Therefore, I'll take one wire from pin number 3, and I will connect to the anode of LED. Okay, and this is the circuit diagram. Then I will connect, these are the two switches. I will use this switch for A, input A, and this switch for input B. Now, I will rearrange this. I will take one wire from 1 and connect to the middle of this part. Similarly, I will take one wire from ground. This is the ground, and I will connect here. I will take one wire from positive and I will connect here. Okay. Similarly, I will take one wire from pin number 2, and I will connect to the center. Then I will connect one wire from ground and with this, and remaining is to the positive supply. First, I will check. Dear friend, this is A. This is B. I will zoom this. See, and this is the using this we can check orbit. First, I will see, dear student, this is A, this is B. First, I will make it 0. 0 means C. Now, in current scenario, value of A is 0 because slider is at this side, and again here for B 0. Means here A equal to 0, B equal to 0, and therefore your output will be at 0. Therefore, again here this LED will be in off position. Now I will start simulation. Serious one. Now here A equal to 0, B equal to 0, therefore Y equal to 0. Now I will make A equal to 0 and B equal to 1. 1 means what? I will slide at this point. See, here. Now LED is glow. boolean, and therefore you can write y equal to 1. See, a equal to 0, b equal to 1, y equal to 1. Now I will again stop this. Then now, dear student, uh, I will make a equal to 0 and b equal to, a equal to 1 and b equal to 0. Now see, I will start. I will make 0. Both, if both are 0, we will get 0. Now I will make a equal to 1 and b equal to 0. Here y equal to 1 means LED is green. Okay. Now this is the third case. Now I will make both are 1, a equal to 1 and b equal to 1. See, if a equal to 1 and b equal to 1, LED is green. Thanks. This is about the orbit truth table. Understood, dear student, this level? Now, dear student, I will show for AND gate. To input AND gate, and for this case, we will use IC number 7408. Okay, or 7408. Okay, and for AND gate, dear student, for each gate consists of two inputs. Therefore, we will find out different code combinations at home. Okay, and for this case, Boolean equation is y equal to a and b, that is y equal to a into b. Okay, product of or we can also AND operation represents logical multiplication. Okay, and if output is denoted by y and inputs are denoted by suppose a and b, therefore we can say that y equal to a and b, or y equal to a into b. Okay, now see, and in this case, output will be at 1 if both inputs are at logic high, that is 1. Means if a equal to 1 and b equal to 1, you will get b equal to 1. Otherwise, your output will be at logic low. And for this case, for AND operation, we will use IC number 7408. Dear student, I will again, I will finish this. Okay, I will take AND gate. So therefore, I will take AND gate and I will place here. Serious one, I will check. See input. This is one is input. Again, 2 is in again second input. And for this case, first for logic gate and output number pin number 3 is output. Therefore, I will again I will connect this LED to pin number 3, 470 ohm of resistor to the cathode of LED, and say another terminal of 470 ohm to the ground. This is the ground line. This is your 6 volt supply. Again here, this is your ground, because this line is connected to the negative of battery, and this second line is connected to the positive. Pin number 14 is power supply. Pin number 7 again is ground. Means the pin structure is same as per your previous IC, that is 7432. Now, but in this case, we will use which operation? AND operation. Okay, now I will make first this is your, see here in this case, a and b, a equal to 1 and b equal to 1. And for this case, for AND, if a equal to 1 and b equal to 1, y equal to a into b, that is 1 into 1 is 1. I will start this simulation and see. Dear student, here LED is glowing, and therefore we can say that y equal to 1. Now I will make both inputs equal to 0. Means click, just click here. See here, a equal to 0, b equal to 0, and y equal to 0. Now I will make a equal to 0 and b equal to 1. Therefore, see again, see, if a equal to 0, b equal to 1, means a into b, that is 0 into 1 is 0, and again y equal to 0. There is no any light. Okay, now I will make a third case, that is I will make a equal to 1, b equal to 0, that is 1 into 0 again 0, and again that is y equal to a into b, that becomes a means 1, b equal to 0, 1 into 0, 0. There is no any light. And last operation is A equal to 1, again B equal to 1, and you will get correct. Understood, dear student? Any doubts you can ask me. And this is about the student and operation Okay, and this is the last case, that is A equal to 1, B equal to 1, and you will get Y equal to 1. This is about the AND operation. Now, after this, I will show about the NAND operation. NAND operation is exactly inverse of AND operation. Now see, now dear student, now I will explain about the NAND gate, and generally NAND gate is formed by a combination of NOT gate and AND gate. That is the NOT of AND, exactly inverse of AND gate. In this case, the output of NAND gate is exactly opposite to that of AND gate. Means in this case, if uh, both are both inputs are equal to at logic high 1, therefore you will get output will be at logic low. Okay, and for this case, if A and B are inputs, therefore we can say that Y equal to bar of A into B, or complement of A into B. Okay, now see, or we can say that Y equal to AB whole bar. And in this case, if A equal to 0, B equal to 0, 0 into 0, and 0 bar equal to 1, output equal to 1. Now, for this case, we will use, dear student, IC number is 7400. For this case, I will replace this. I will shift this. I will put here. I will check inputs first. Input again here, pin number 1 and 2 are inputs, 3 is output. Again 4 and 5 are inputs, 6 is output, 7 is ground, 8 is input, 8 is output, and 9 and 10 are inputs. Again pin number uh, 11 is output, and pin number 12 and 13 are inputs, and again 14, pin number 14 is for power supply. See, this is power supply line, ground line. Here ground line is connected to here upper one, and the second line is connected to here positive. See, plus is okay. Now same here, dear student. A equal to, this is A, this is your B, and pin number 3 is connected to LED, that is output. And now I will start simulation. First I will take A equal to 1 and B equal to 1. See, okay. And for A equal to 1 and B equal to 1, output 1 into 1 is 1, and bar 1 equal to 0. I will start, dear students, simulation. Yes, see, dear student, for A equal to 1 and B equal to 1, there is no light, means 1 into 1 equal to 1, and bar 1 equal to 0. Therefore, dear student, I will make here A equal to 0 and B equal to 0. Just click on here and here. See, dear student, LED is green, and therefore we can say that, see, here A equal to 0, B equal to 0, and here in this case, for NAND gate, Y equal to A into B whole bar. Therefore, A equal to 0, B equal to 0 means 0 into 0, 0, and 0 bar equal to 1. Therefore, here you will get light through this LED. Okay, light emitting diode will give light, and therefore we can say that Y equal to 1. Now, next case is, I will make A equal to 0 and B equal to 1. Just click on here. Again, therefore, A equal to 0, B equal to 1. You will get Y equal to 1, because A equal to 0, B equal to 1. 0 into 1 is 0, but 0 bar equal to 1. Therefore, here you will get your student light. Now, I will make A equal to 1 and B equal to 0. A equal to 1, B equal to 0. A 1 into 0 is 0, again 0 bar equal to 1, again we will get light. Thus A equal to, for NAND gate, if A equal to 1, B equal to 0, Y equal to 1. And last case is again when A equal to 1 and B equal to 1, 1 into 1 is 1, and 1 bar equal to 0. Now see, is there is no right. Therefore, we can say that a if a equal to and b equal to 1, therefore the y equal to 0. And this is about, dear student, NAND gate. Okay. Then next, dear student, I will explain about the NOR gate. And NOR gate is exactly inverse of OR gate. Okay, means if a and b are inputs, therefore we can say that y equal to a plus b whole bar. Okay, and this is a combination of NOR and OR gate. And for NOR gate, dear student, we will use IC number 7402. See your left hand side. Now I will remove this IC and I will select and just drag. Then check, dear student. This is your pin output one. Therefore, I will delete all these. Okay. Okay, dear student. For NOR gate, IC number is 7402. NOR gate is formed by connecting output of NOT gate to the input of OR gate. Now see, dear student, we can say that that is here. Output of NOR gate is a combination of NOT and OR. That is output of OR. We can connect to the input of NOT gate. Okay, that is output of NOT gate, and we will take output of NOR is uh, at the pin terminal of NOR. Now see, dear student, uh, here uh, y equal Boolean equation is y equal to a plus b whole bar. And in this case, dear student, when y is equal to 0 and b equal to 0, 0 plus 0 is 0 and 0 y equal to 1. Now, since not it, I will first check pin connection. See, dear student, spot, white spot means pin number 1. And in this case, dear student, pin number 1 is output. Pin number 2 and 3 are inputs. Okay, therefore, I will take one wire and I will connect to the center of this switch. Then I will take one more wire and I will connect to the center of switch. Okay. Now, dear student, I will take one wire from ground and I will connect to the switches. Simple connections, and remaining terminal to the power supply. Okay, this is the basic connection. And then for this case, I will take one wire from pin number 1 and I will connect to the dear student anode of LED. Then I will take one wire from pin number 7 and I will connect to the ground. See? And I will take one wire from pin number 14 and connect to here. Okay, this is the basic. Now I will start, then click on start simulation. And dear student, first I will connect pin number A, that is A and B. A and B is equal to, first see, dear student, from this diagram I will connect A and B equal to 0. Just click here and click here. See, for A and B, A equal to 0, B equal to 0. 0 into 0 is 0 and 0 bar equal to 1. Therefore, here we will get light. Okay, LED is green means Y equal to 1. Now I will make next point is A equal to 0. A equal to 0, but B equal to 1. And for this case, dear student, if B equal to 1, therefore 0 into 1 is 0 and you will get 0 bar equal to 1. Now, if here, please just click, therefore you will get the light. See, dear student, if okay, 0, if A equal to 0 and B equal to 1, 0 into 1 is 0. Okay, and therefore, sorry, student, 0 plus 1 is 1 and you will get 1 bar equal to 0. Now I will make A equal to 1 and B equal to 0. and I will stop simulation. Okay, so a equal to a is what 1, b equal to 0, 1 plus 0 is 1, and 1 bar equal to 1 bar equal to 0. Now I will start this simulation. So answer is 0. Now I will make a equal to 0. I will stop this. I will make this is your 0, and this is your 1. I will start this. I will make this is 0 and this is 1. See, 0 plus 1 is 1 and 1 bar equal to 0. Here there is no line. I will again make both equal to 1. 1 plus 1 is 1 here, and 1 bar equal to 0. Again see here all operations. 0 plus 0 is 0, 0 bar equal to 1. Next is a equal to 0, b equal to 1. 0 plus 1 is 1, 1 bar equal to 0. Next is 1, 0, 1 plus 0 is 1, 1 bar is 3. And last is 1 plus 1 is 1, and 1 bar equal to 0. Okay, this is about which way this one. This is about the orbit, that is the combination of not orbit. Okay, and next is X-orbit, exclusive orbit. And in this case, in case of exclusive orbit, which is the combination of the exclusive orbit uh, can be written as which output is for a bar b into b plus a b bar, that is the which consists of AND gate, OR gate, and NOR gate. And in this case, we have to learn when both inputs are at the same level, that is if a equal to b equal to 0, you will get output equal to 0. Means again, if a equal to b equal to 1, you will get output again will be at logic low. Means in this case, you will get output is at high level when either one of the inputs is high, but not both inputs are at same level. Okay, means if a equal to 1 and b equal to 0, you will get output 1. If a equal to 0 and b equal to 1, you will get output 1. Means when both inputs are uneven, you will get your output as logic. Now, and for this case, dear student, we will use XOR gate, and for XOR gate, I will select dear student 7486. Okay, 7486. See, I will remove this. I will remove this. I will. Okay. XOR. I will use. I will check inputs. Input 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Power 1 and 2 are inputs. Therefore, I will take one wire from 1 and I will connect it. I will take one more wire to connect it. Okay. Then I will take one more wire from ground. I will take one wire from pin number 7 and connect to the ground. Okay. Here you can this input A, input B. Then pin number 3 is output C. Output. I will take one wire and connect to the anode of LED. Okay. Remaining is same. And then first, dear student, I will start simulation. First, I will take both equal to 0. Therefore, just click here, both equal to 0. There is no light, therefore phi equal to 0. Then, dear student, a equal to 0 and b equal to 1. Therefore, just click here. Dear student, see, there is light, that is therefore here we can say that y equal to 1. Next case is uh, make a equal to 1, just click here, and b equal to 0. A equal to 1, b equal to 0, again we will get light, that is y equal to 1. And last case is a equal to 0, 1 and b equal to 1. See, therefore we can say that a y equal to logic here output will be at logic loop. And this is about the exclusive OR gate. And here we use IC number 7486, which consists of core, that is 4 uh, XOR gates. Okay, and therefore in this case we can say that y equal to a bar b plus ab bar. And this is about the student OR gate, AND gate, NAND gate, NOR gate, and exclusive OR. Yes, if you have any doubt and you using a Tinkercad, you can first download Tinkercad and then you can do at home also. If you have any query, you can contact me anytime. Okay, my email ID is kulkarni@yahoo.com and my phone number is 92210527. If you have any query, you can contact or you can use my WhatsApp number. Thank you, dear student. Thank you so much. Thank you.